Hello, everybody. Welcome to my channel, Island Daily. My name is Dr. Eamon, and I'm an optometrist. And today we're going to understand what is back vertex distance and how it's going to make an impact on the prescription. So let's get started. So the back vertex distance is actually the distance from the back surface of the optical lens to the apex of the cornea, right? So the back surface of the lens to the front surface or the apex of the cornea. Now, why is it very important and what significance does it have? It has a very major contribution when you're switching from the spectacles towards contact lenses, and also when you're moving towards refractive surgery. So for the refractive surgery, you must know at which distance you are doing the refraction. In any case, if you are entering a wrong BVD, it is going to result in an overcorrection or an undercorrection. So let me explain to you how is it going to happen. So you might have noticed that some people wear their spectacles way too far from their eyes, and some people wear it very close to their eyes. And here I've drawn a picture of a person who is wearing a presbyopic spectacles, and he is wearing those spectacles very far from his eyes. And this child right here has a minus prescription, and he is wearing it very close to his eyes. So what actually happens? If the prescription is in minus, if the person is wearing a concave lens, taking it far away from the eyes will reduce its effective power. And if the minus lens is closer to the eyes, it's going to increase the effective power of the minus lens. Vice versa, if a person is wearing a plus lens, a convex lens, taking it far away from the eyes, increasing the BVD actually, it is actually going to increase the effective power. And if the same plus lens is closer to the eyes, it is going to reduce its effective power. Now, what is this effective power actually? The effective power means that even if you're wearing the right prescription, even if you have a prescription of -5 diopters, if you are using it far away, if the BVD is increased, you are going to feel like you're wearing a -4.50 diopter sphere of prescription, right? So effective power is something that is subjective. It is actually going to make you feel like you're wearing a wrong prescription, though your prescription is right. So BVD is actually very important, and it will uh, let other people know how intelligent you are in your field and how much you know about your field. Now, first, if you're going to shift from spectacles to the contact lenses, there is just one formula, and that is right. There's one thing I need to tell you that the back vertex distance is going to matter only if your prescription is more than 4 diopters, right? So if your prescription is less than 4 diopters, no matter what, you are not going to play with the BVD, right? So if only your prescription is greater than 4 diopters, only then you're going to go for the BVD, right? rather you are concerned with the contact lenses or with the refractive surgery. So here in this case, the patient has a prescription of -8 diopters, right? And the person wishes to have contact lenses made. So the BVD I'm taking right over here is 14 millimeters. And in this formula, you take BVD in meters. So from the millimeters, you have to divide it with 1,000 and you will get 0.014, right? Now, you have to put the bracket, right, and multiply with it -8, right? Now, first you have to solve this section. You will get 0.112 is going to get add, and by dividing it, you will get -7.19, which is clinically equivalent to -7.25, right? So this is actually, you are subtracting all that 14 millimeters of BVD from the prescription. And now you get -7.25. That is your final prescription. You see how the vertex distance is actually influencing, actually changing the prescription. Now, what if the person had 14 millimeter of BVD while I was refracting the patient. But now, when he came to me, he has a complaint of severe headache, and he says that his prescription is not correct, though the prescription is same. But the glasses he's wearing has a BVD of 20 millimeters. Now, first I have to say that he was wearing a -8 diopter pair of prescription, right? Now, it's minus and the BVD is actually increasing. Since the BVD is increasing, this means the effective power is decreasing, right? Now, for that problem, there is a formula and that is d squared over 1,000. Now I'm going to take square of this and divide it with 1,000. I will get 64 divided by 1,000, and that is 0.064, right? Now, the BVD has changed from 14 to 20 millimeter. That means there was a change of 6 millimeters, right? Now I'm going to multiply the 6 millimeters with 0.064, which will become 0.384. Now, clinically, we do not have 0.384, right? So it will be equivalent to 0.50. Now I'm going to subtract this since the refractive power has reduced, because first it was 14 millimeter and now it's 20 millimeters. So increasing the back vertex distance in the minus lens will reduce its effectivity, right? So now I'm going to add this 0.50 in the prescription and I will get 8.50 diopters. So this is going to be the exact prescription for that person if he is going to continue wearing that spectacles at a distance of 20 millimeters, right? Now, this was for this fair. What happens if the prescription is going to be like this, right? Now, for that case, we know a rule. 180 is the axis, and we know that the power of the cylinder at the axis is 0. So here we have -7 diopter sphere, which is the power of the sphere only. And at the meridian, which is 90 degree, we will have -12. right? So what we will do, we will actually solve each of the meridian. So for that, we will get for -7 and for -12. You guys can also pause the video and come back to check your answer. Right? So right here, it's the BVD before was 14 and the new BVD was 20 millimeter. We are going to keep the same scenario just for the cylinder. Now, what I'm going to do is multiply 0.049 with 6 millimeter because that's the difference between 14 and 20. I will get 0.294, right? And right here, I will multiply it with 6. It is going to make 0.864. Now I will actually add 0.864 for, so it is clinically significant to minus 0.75. I'm going to add 0.75 and that is going to make 12.75 diopter sphere. And right over here, this right here is clinically equivalent to 0.25. So I'm actually going to add, that was 7, right? I'm going to add this in 7.25. Now, this right here is a spherical prescription. Now, in order to calculate this power in the sphere cylinder form, what we will get is you will only take difference of cylinder and the sphere, and you will get 5.5, right? So the final prescription is going to be minus 7.25 and minus 5.50 at 180. And what was the prescription before? It was minus 7, right? It was minus 7 and minus 5 at 180, and now it is minus 7.25 with minus 5.50 at 180, with a change in BVD from 14 to 20 millimeter. So this was whole for today. I hope I have made everything clear. If you guys have any questions, you can ask in the comment section, and do like and share my videos and do subscribe to my channel. Thank you very much.